Hello guys, welcome to our channel today. We're going to briefly explain you about dark matter and dark energy beneath the velvet curtain of night. The universe stretches outward in a spectacle of light. Stars scatter across the firmament like embers of an eternal fire, their brilliance reaching across gulfs of time and space. Galaxies swirl in grand spirals, colossal cities of suns suspended within an invisible ocean. Nebulae bloom like stained glass against the dark, clouds of dust and gas where new stars are born. To the human eye, this cosmic landscape seems complete, a boundless empire of matter illuminated by its own radiance. It feels as though everything that exists, everything that defines the universe, is written in the glowing script of starlight. For centuries, this was the image humanity carried. The universe as a cathedral of stars. Ancient astronomers mapped constellations and believed them to be the skeletal framework of heaven. Telescopes sharpened this vision, revealing more stars, more galaxies, and ever more intricate structures. With every new discovery, the impression deepened. The visible cosmos is the universe itself, a collection of luminous bodies scattered through infinite night. But reality, as science slowly revealed, is far stranger. What we see, even with the most powerful telescopes, is only the thinnest veil of a much deeper truth. The stars, the galaxies, the glowing gas, all the luminous matter that fills our sky, amount to less than 5% of what the universe truly contains. 95% remains hidden, beyond sight, beyond touch, yet it exerts an inescapable influence on everything. Dark matter, the invisible glue, holds galaxies together, preventing them from flying apart. Dark energy, a mysterious pressure, accelerates the expansion of space itself, driving galaxies away from one another faster and faster. Together, these unseen components dominate the cosmos, dictating its shape, its fate, and its every motion. The known universe, all that humanity has ever seen, is a fragile island, floating in an ocean of the unknown. And the great paradox emerges. The visible universe dazzles the senses. It is nothing more than a faint embroidery stitched upon a vast, invisible fabric. Here begins the central enigma of modern cosmology, that everything familiar, every star and every planet, every mountain and every human life, is built upon a minority fraction of the cosmos. The true universe, the majority realm, remains shrouded in mystery, silent, invisible, and waiting to be uncovered. In the early decades of the 20th century, a strange unease began to stir within astronomy. Telescopes had grown sharper, photographic plates more precise, and calculations more exact. Humanity's eyes could now pierce the vast architecture of galaxy clusters, the immense congregations of hundreds, sometimes thousands, of galaxies bound together in colossal swarms. It was in 1933, within the quiet halls of the California Institute of Technology, that a Swiss astronomer named Fritz Zwicky turned his gaze toward the Coma Cluster, a massive gathering of galaxies suspended more than 300 million light years away. With the aid of the Mount Wilson Observatory, Zwicky measured the speeds at which these galaxies orbited within the cluster. What he found was bewildering. The galaxies moved far too quickly. By the logic of Newtonian gravity, the visible matter, the stars and gas within those galaxies, was nowhere near sufficient to hold them together. At such furious speeds, the galaxies should have torn free of their cluster, scattering into the abyss like sparks blown from a fire. And yet, the cluster endured. To explain this paradox, Zwicky invoked something radical. The presence of an invisible mass, vastly greater than the matter astronomers could see. He called it Dunkel Materie, dark matter. According to his calculations, the Coma cluster contained nearly 400 times more mass than was visible in stars. The majority of the cluster's substance was hidden, unseen, and yet it exerted a gravitational grip strong enough to bind entire galaxies in its grasp. The claim was extraordinary, even shocking. For centuries, astronomy had trusted the eye, the telescope the shining evidence of light. To suggest that most of the universe was invisible was to upend the very foundation of observation. If Zwicky was right, then human beings have been misled by the cosmos itself, dazzled by the brilliance of stars while blind to the substance that truly defined reality. But the scientific community was not ready to listen. Zwicky was known for his sharp tongue and abrasive manner, often calling his colleagues spherical bastards, round because they were bastards no matter how one looked at them. His personality earned him few allies, and his proposal of unseen matter seemed too speculative, too outrageous to be taken seriously. Many dismissed his results as flawed measurements, errors of assumption, or exaggerations born of his eccentricity. For decades, his dark matter was relegated to the margins of astronomy, a strange footnote in the annals of cosmic speculation. The universe, it was assumed, could be explained by what was visible. Stars and gas, after all, were plentiful, and their light could be trusted. Yet, beneath the skepticism, Zwicky's whisper lingered. The Coma cluster remained an enigma, a puzzle that refused to disappear. Other astronomers began to note small irregularities in galactic motions, subtle hints that something unseen might be at play. Though his work was neglected, the seed of a cosmic mystery had been planted. In hindsight, Zwicky's insight appears almost prophetic. His calculations, crude by modern standards, pointed to a truth so profound that it would take nearly half a century for science to fully recognize it. The universe is dominated not by what shines, but by what does not. Here, in the shadows of the Coma cluster, the first whisper of dark matter was heard. Faint, ignored, but persistent. It was a whisper that foretold a new era of cosmology, one in which humanity would have to confront the unsettling reality that the cosmos is not as it appears. And though Zwicky's voice was often dismissed in his lifetime, history would reveal him as the reluctant prophet of the invisible, the astronomer who first glimpsed the vast, unseen majority of the universe.
In the great silence of space, light is the only messenger that travels without hesitation. From the hearts of stars, from the depths of galaxies, it crosses billions of years, carrying the memory of creation itself. Yet even this ancient traveler, thought to move in straight and perfect lines, is not immune to the will of gravity. Albert Einstein's general theory of relativity, unveiled in 1915, transformed the concept of gravity. No longer was it a mere force pulling objects together. Instead, it became the warping of space-time itself. Matter bends the geometry of the universe, and light, ever obedient to that curvature, is forced to follow. In this new vision, mass acts as both sculptor and jailer, shaping the very paths along which light must flow. This revelation meant that light from distant stars could be deflected by the invisible grip of intervening mass. Galaxies, clusters, and even unseen matter could act like lenses, bending and distorting the images of more distant objects. The universe itself became a vast optical instrument, where gravity played the role of glass. This phenomenon, known as gravitational lensing, was once only a theoretical prediction. Yet as telescopes grew sharper and surveys more ambitious, the evidence appeared unmistakably. Quasars split into mirrored doubles, distant galaxies smeared into luminous arcs, rings of light encircling massive clusters. Each distortion told the same story. There was more mass-bending light than visible matter could account for. Gravitational lensing became a window into the invisible. By carefully measuring the way light from distant galaxies was twisted and stretched, astronomers could trace the contours of unseen structures. Maps of galaxy clusters revealed halos far larger than the stars within them, ghostly scaffolds of dark matter extending into space like invisible skeletons. The light of the universe, distorted and rearranged, sketched out a portrait of what could not be seen. Among the most striking revelations came in 2006 with the observation of a cosmic collision that would become a cornerstone in the case for dark matter, the Bullet Cluster. Two galaxy clusters, each containing thousands of galaxies, had collided in a cataclysmic event spanning millions of years. Stars, separated by immense distances, passed through largely unscathed. But the hot plasma, the luminous gas that makes up most of a cluster's visible matter, slammed together and slowed, emitting X-rays that telescopes like Chandra could capture. Yet when astronomers mapped the gravitational field of the bullet cluster using gravitational lensing, a startling picture emerged. The bulk of the mass did not lie with the slowed, luminous gas. Instead, it aligned with the galaxies themselves, which had sailed past each other with little resistance. The invisible component, the dark matter, had followed the galaxies, leaving the glowing gas behind. Here, in this silent collision hundreds of millions of light years away, the invisible had left its mark. It was as if nature had drawn a line in the sand, separating the matter we could see from the matter that truly ruled the cosmos. The bullet cluster became a photograph of the unseen, a rare moment when dark matter revealed its presence not by speculation, but by geometry itself. The implications were profound. No theory of modified gravity could easily explain such a separation, where the majority of mass seemed to march to its own laws, ignoring the bright plasma left behind. The invisible scaffolding that Zwicky had once whispered of, and Rubin had traced in galactic curves, now stood exposed in the grandest of cosmic experiments, a cluster torn apart by gravity, sketched in distorted light. But the bullet cluster was not alone. Across the cosmos, astronomers found similar collisions, similar separations, similar signatures of dark matter at work. Each one added weight to the evidence that the universe is not defined by the light it emits, but by the shadows it bends. Gravitational lensing continues to be one of the most powerful tools in modern cosmology. Space observatories and vast sky surveys chart the distortions across millions of galaxies, mapping the dark web that stretches between them. The results are haunting. A universe crisscrossed by filaments of dark matter, weaving galaxies into clusters, clusters into superclusters, and superclusters into a vast cosmic web. The luminous universe, the stars and galaxies that dazzle the eye, floats upon this invisible framework. Without it, galaxies would dissolve, clusters would scatter, and the great tapestry of structure would never have formed. And yet, despite its power, this evidence is still indirect. The bullet cluster may be a photograph of the invisible, but it is a photograph painted in distortions and absences. Dark matter refuses to reveal itself directly. It whispers through gravity, shaping the paths of photons but never emitting one of its own. There is a quiet poetry in this silence. The cosmos reveals its deepest truths not in brilliance, but in shadows. Light itself, the most trusted messenger, becomes a tool for uncovering what hides beyond it. The universe, in bending its own beams, sketches a portrait of a reality we cannot otherwise perceive. What, then, is dark matter? If it can separate cleanly from luminous gas, if it can sculpt galaxies and dictate the web of the cosmos, then what form does it take? Is it made of particles, elusive and ghostly, passing through stars and planets without a trace? Or is it something deeper still, a new law of physics, a shadow geometry written into space-time itself? The bullet cluster does not answer these questions. It merely insists that the unseen exists. It is a cosmic signpost, pointing toward a deeper mystery. As astronomers refine their maps of gravitational lensing, they continue to draw charts of an invisible landscape, mountains and valleys of mass, unseen but undeniable. In these maps, dark matter is no longer speculation, no longer a whisper. It is the silent architecture of the universe, bending light into arcs of revelation. The cosmos has given humanity a paradox. To see the invisible, one must study the distortions of light. The universe hides its majority in darkness, yet reveals it through the bending of its oldest messenger. And in these shadows bent by gravity, the story of the unseen continues to unfold. Beneath mountains, under kilometers of rock, and deep within the Earth's crust, science waits in silence. In caverns carved away from sunlight and shielded from the noise of the surface world, great instruments stand vigil. They do not search for starlight, nor for the bursts of distant galaxies, but for the faintest possible whisper, the touch of a particle that should exist, yet has never been seen. This is the silent frontier of physics, the search for dark matter. For decades, astronomers have traced its influence across the cosmos. They have seen galaxies spinning too quickly, clusters bending light in impossible ways, and cosmic webs stitched together by invisible scaffolds. But gravity, though persuasive, speaks only indirectly. If dark matter is real, then it must be something more than an abstraction. It must have substance. And if it has substance, it must be made of something. Particles as yet unknown, passing through the universe invisibly, without interacting with the familiar matter that makes stars and life. The leading idea has long been the WIMP, the weakly interacting massive particle. Born from theories that extend beyond the standard model of particle physics, WIMPs are envisioned as heavy, stable particles that interact so rarely with ordinary matter that trillions could pass through the human body every second without leaving a trace. If true, they would be the silent majority of the cosmos, threading every star, every planet, and every galaxy with their unseen presence. To capture one requires extraordinary patience. On the surface of the Earth, ordinary cosmic rays shower down endlessly, overwhelming any attempt to detect a rare signal. So scientists dig deep underground, building enormous detectors within shielded caverns where rock filters out the constant noise of the universe. Here stand instruments such as Xenon 1T, buried beneath the Italian Alps in the Gran Sasso Laboratory, a vast tank of liquid xenon, cooled to cryogenic temperatures, waits in darkness. Should a dark matter particle strike an atom of xenon, it would create a faint flash of light, a ripple of ionization, a fingerprint of the invisible. Across the world, other sentinels stand watch. LUX Zeppelin in the depths of South Dakota's Black Hills, with its immense vat of xenon. Pandax in the mountains of China, another liquid xenon detector, exquisitely sensitive. Each one listens in perfect stillness, year after year, for a signal that may never come. But so far, the silence has been absolute. No WIMP has revealed itself. Decades of searching have turned up nothing but shadows. The detectors grow larger, more refined, more sensitive than ever before, yet the dark matter refuses to betray its presence. This long silence has deepened the mystery. For if dark matter is not a WIMP, then what is it? Some theories point to the axion, a particle so light, so delicate, that it could slip unnoticed through the universe, born not from colliders, but from the twisting fields of quantum chromodynamics. Axions would behave not like bullets, but like waves, subtle ripples that might be detected not through flashes of light, but through the faint turning of magnetic fields. To this end, experiments like ADMX, the Axion Dark Matter Experiment, tune themselves like radios listening for a cosmic hum. Others suggest sterile neutrinos, ghostly cousins of the known neutrinos that already pass effortlessly through matter. Unlike their active relatives, these sterile neutrinos would not interact through the weak nuclear force, only through gravity, making them nearly impossible to catch. Yet in their collective abundance, they might form the unseen mass that binds the cosmos together. The search has expanded beyond the underground. Particle accelerators such as CERN's Large Hadron Collider have sought to create dark matter particles in the violence of collisions, smashing protons together at nearly the speed of light in the hope that energy might vanish into unseen forms. But even here, where physics reaches its most extreme, dark, matter remains hidden. Each failure reshapes the question. Perhaps dark matter is not a particle at all, but something stranger. Perhaps it is a spectrum of particles, an entire hidden sector of physics, a shadow universe that overlaps with our own, but refuses to touch it. Perhaps it is not matter in the conventional sense, but a reflection of deeper geometry, a curvature of space-time that masquerades as mass. The silence has grown almost philosophical. What does it mean to search for something that refuses to be found? How long can science chase an absence before asking if the question itself must change? The bullet cluster and gravitational lensing maps insist that unseen mass is there. The mathematics of cosmology require it. And yet the detectors remain mute. This tension has begun to fracture the certainty of earlier decades. Some physicists argue that the search has been misguided, that dark matter may not exist as particles at all. They point instead to modifications of gravity, laws not yet written, in which space-time itself behaves differently at large scales. Others maintain their faith in particles, convinced that the silence is not an absence, but a challenge. The universe is simply telling us that its mysteries lie deeper than we imagined. There is a haunting beauty in these underground caverns, where tanks of liquid xenon glow faintly in the dark, waiting for a single, impossible collision. Each detector is like an ear pressed against the silence of the cosmos, listening for a sound that may never arrive. The patience of these machines mirrors the patience of humanity itself, a willingness to wait decades, to spend lifetimes, in pursuit of truths that lie beyond immediate reach. The story of dark matter has become a story of silence. And silence, in science, is not nothingness. It is a signal of its own. It is the whisper of new possibilities, of theories yet unmade, of directions unexplored. Perhaps dark matter is a whim, and the next generation of detectors will finally capture its elusive spark. Perhaps it is an axion, humming softly through magnetic fields. Perhaps it is sterile neutrinos, drifting unseen through the cosmos. Or perhaps it is none of these, but something beyond imagination, a clue to a new physics that will redefine everything we think we know. In the caverns beneath mountains, the vigil continues. Detectors wait, listening in silence, as the universe withholds its secrets. The search itself has become a metaphor for the human condition, a reminder that to live in a cosmos ruled by shadows is to pursue knowledge without guarantee of discovery. And yet, this pursuit is what defines humanity's place in the universe. Not the answers already known, but the questions still asked. The silence of dark matter is not the end of the story. It is the invitation to continue searching, to keep listening, to accept that the most profound truths may be those hidden deepest in the dark.
In the late 1990s, a revelation shook the very foundation of cosmology. Astronomers, charting the glow of ancient supernovae, expected to find that the universe's expansion was slowing down. Gravity, after all, is relentless, and even across cosmic distances, it should tug upon galaxies, slowing their outward flight. But the data told a different story. The galaxies were not decelerating, they were accelerating, racing apart faster with each passing epoch. The cosmos was not merely expanding, it was being pushed outward, as though some invisible hand were prying open the fabric of reality itself. This force came to be called dark energy, a term as mysterious as the phenomenon it names. Unlike dark matter, which reveals itself through the pull of gravity, dark energy resists comprehension at a deeper level. It does not gather in halos, it does not bend light, and it does not form structures. Instead, it permeates all of space, an unseen pressure woven into the very geometry of the universe. To describe it, physicists often begin with Einstein. His equations of general relativity allow for a cosmological constant, a uniform energy that fills the vacuum of space. At first, Einstein introduced this constant to keep the universe static, fearing the implications of expansion. Later, he discarded it, calling it his greatest blunder. Yet the accelerating cosmos has revived it. Perhaps space itself has a constant energy, driving galaxies apart forever. But the constant may not be constant at all. Some cosmologists speak of quintessence, a dynamic form of dark energy, not a fixed property, but a field that evolves over time. In this vision, dark energy is not a static backdrop, but a living presence, waxing and waning, shaping the universe's expansion in rhythms still unknown. The name recalls the ancient philosophers who spoke of a fifth element beyond earth, air, fire, and water. Ether, the quintessence, the hidden substance of the heavens. Now, modern physics borrows their word to describe a force that remains beyond direct detection, yet sculpts the destiny of all that exists. Quintessence imagines dark energy as a scalar field, similar in concept to the Higgs field that gives particles their mass. mass. Such a field could vary in intensity, changing the rate of expansion as epochs pass. If true, the universe may not be ruled by a simple constant, but by a field as alive and unpredictable as weather, slowly shifting across cosmic timescales. Yet the strangeness does not end there, for if dark energy evolves, it may take on even more exotic forms. Some theories predict phantom energy, a form of dark energy with an equation of state more negative than that of a cosmological constant. Unlike ordinary dark energy, phantom energy would not only accelerate expansion, but do so with growing violence. In this scenario, the cosmos would face a terrifying fate, the Big Rip. As phantom energy strengthens, the acceleration would become unstoppable. First, galaxies would be torn apart, their clusters unbound. Stars would drift away from one another as gravity itself loses its grip. Then, solar systems would dissolve, planets ripped from their orbits. In the final moments, even atoms would not survive. The very fabric of matter would be unspooled by the relentless expansion. Space-time itself would rip apart, leaving only an ever-thinning nothingness. It is a scenario both terrifying and profoundly alien, a vision of an ending not with fire or collapse, but with silence and separation, as everything is torn away from everything else. But the truth remains uncertain. The supernova data, the cosmic microwave background, and the distribution of galaxies all suggest dark energy behaves like a cosmological constant, at least for now. Yet the margin of error leaves room for doubt. Perhaps the constant is constant, or perhaps it is slowly changing, and the universe is already on a trajectory toward futures stranger than imagination. The challenge is not simply one of measurement, but of meaning. For dark energy, in whatever form it takes, is not a detail at the margins of cosmology. It is the dominant actor on the cosmic stage. Nearly 70% of the universe is composed of this unseen energy, dictating its ultimate fate. All the stars, galaxies, and dark matter that fill the skies account for less than one-third. The universe is ruled not by what can be seen, but by what cannot. This realization forces cosmologists into profound questions. If dark energy is constant, then the universe will expand forever, cooling into emptiness, its galaxies drifting apart until no light bridges the gaps. A slow death of heat and memory, the heat death of the cosmos. If it is quintessence, the story becomes less certain. Perhaps the field will weaken, allowing gravity to reassert itself, pulling the universe back into a final collapse. The Big Crunch, where all matter and light fall once more into a fiery origin. Or perhaps it will evolve unpredictably, shifting the destiny of the cosmos in ways science has not yet imagined. If it is phantom energy, then time itself may end in the violent unmaking of the Big Rip. Each possibility redefines not only the future, but the present, shaping the way humanity understands its place in existence. For to ask what dark energy is to ask what kind of universe this truly is, a cosmos of permanence, of cycles, or of catastrophic endings. The strangeness of dark energy is that it confronts science with humility. It reveals that the greatest force in the cosmos is also the least understood. It reminds us that the universe we inhabit is not bound by human expectations, but by laws written in a language yet to be deciphered. Telescopes and satellites continue the search. The European Space Agency's Euclid mission, launched to chart the dark universe, maps the geometry of galaxies to constrain the nature of dark energy. NASA's upcoming Nancy Grace Roman Space Telescope promises to trace supernovae and cosmic structures with unprecedented precision. Each new data set offers a glimpse at the contours of the unknown, narrowing the possibilities, but never yet delivering certainty. Still, in the vast silence of space, the question remains unresolved. Is dark energy a constant hum beneath creation, or a shifting field, alive with potential? Is it the whisper of phantom forces that will one day rip reality apart, or simply the quiet presence of energy in the vacuum? stretching the universe forever into darkness? The answers remain hidden, folded into the fabric of space-time itself. But the strangeness of dark energy lies not only in its effects, but in its meaning. It forces humanity to reckon with a cosmos whose fate is not fixed, but suspended in mystery. It demands reflection on what it means to live in a universe where the majority of reality is not seen, not touched, and not yet understood. And in that strangeness lies both awe and unease. For the universe, vast and ancient, is not merely a stage for stars and galaxies. It is a living mystery, shaped by forces beyond comprehension, carrying all of existence toward an ending still unknown. For nearly a century, the shadow of dark matter has haunted cosmology, invisible, elusive, untouchable, yet undeniable in its gravitational command. Galaxies rotate too quickly, clusters hold together against the odds, light bends as though pulled by unseen hands. All of these signs point toward a hidden mass, and yet some scientists have dared to ask a heretical question. What if the missing matter does not exist at all? Perhaps the cosmos is not hiding particles in the dark. Perhaps it is hiding a flaw in our understanding of gravity itself. In the early 1980s, the Israeli physicist Mordechai Milgram proposed an audacious idea: modified Newtonian dynamics, or MOND. Newton's laws, he argued, worked well at ordinary scales: the fall of an apple, the orbit of Earth, the dance of the moon. But at the delicate, ghostly edges of galaxies, where accelerations are faint, perhaps Newton's equations falter. Milgram's theory introduced a threshold, a scale below which gravity would behave differently. Instead of fading with distance as quickly as Newton and Einstein prescribed, the pull of gravity would linger, stronger than expected. This adjustment, though simple, could explain the flat rotation curves of galaxies without invoking an unseen halo of dark matter. The galaxies in this vision were not bound by shadows, but by laws of gravity subtly miswritten. For a time, MOND seemed to whisper solution. Spiral galaxies, with their puzzlingly steady rotations, fell neatly into place under its rules. The elegance was seductive. Instead of inventing new matter, MOND invited physicists to rewrite the script of nature itself. But elegance is not truth. As observations deepened, cracks emerged. While MOND explained galactic rotation, it stumbled when confronted with larger structures. Galaxy clusters, vast cities of stars and plasma, defied its corrections. Their binding mass remained far too great to be explained by visible matter alone. Even under Milgram's altered equations, the shadows persisted. Relativity, too, stood in the way. Einstein's theory governs not just motion, but the bending of light, the flow of time, the curvature of space-time itself. To remain credible, any new theory had to extend beyond Newton into a fully relativistic form. This gave birth to Tevis, tensor vector scalar theory, a more ambitious attempt to weave MOND into the fabric of relativity. Tevis promised to account not only for galaxy rotations, but also for gravitational lensing, the bending of light around massive objects. It sought to give MOND the spine it needed to compete with dark matter on equal footing. For a while, the theory offered hope, a vision of physics cleansed of invisible scaffolds, explained instead by equations reshaped at their foundation. But the universe proved uncooperative. The decisive blow came from cosmic laboratories far larger than any experiment on Earth. Observations of the Bullet Cluster and later other colliding clusters showed mass distributions that MOND and Tevis could not reconcile. Here, luminous gas and galaxies had parted ways, leaving gravitational fields aligned not with visible matter, but with the unseen. Modified gravity alone could not account for this separation. To preserve itself, even Tevis had to quietly smuggle in some form of additional unseen matter. The irony was stark. The very theories designed to banish dark matter found themselves compelled to reintroduce it in disguise. And so, one by one, the modified gravity models began to falter. Some could explain galaxies, but not clusters. Others could handle lensing, but not the cosmic microwave background. The universe, it seemed, demanded more than a simple rewrite of gravity's script. It demanded a hidden mass, silent yet sovereign, woven into the cosmos. Still, the attempts themselves revealed something profound. They spoke of the human reluctance to abandon old frameworks. Newton's laws had ruled for centuries. Einstein's relativity had become the foundation of modern physics. To question them, even slightly, felt like heresy. And yet, science thrives on heresy, on boldness, on those willing to ask if even the most trusted laws are incomplete. The failures of Mond and Tevis did not merely strengthen the case for dark matter. They illuminated the psychology of science itself. Our attachment to simplicity, to elegance, to the comfort of familiar equations. The universe, indifferent to human preference, refuses to conform. Even now, some physicists continue to explore modified gravity, variants of Mond, hybrid models that combine new dynamics with unseen matter, or entirely fresh approaches such as emergent gravity. The idea that gravity is not fundamental at all, but arises from deeper principles of information and entropy. These ideas remain at the frontier, fragile but persistent. They remind us that science is not merely a march toward truth, but a dialogue between imagination and evidence. For in the vast unknowns of dark matter and dark energy, it is not unthinkable that the laws of physics themselves may yet shift. But the lesson of the last 4 decades is humbling. Every time gravity has been tested against the universe, it has bent but not broken. Einstein's equations, born more than a century ago, continue to predict with astonishing accuracy the structure of space, the dance of light, and the arc of galaxies. The shadows, it seems, are not born of a flawed theory of gravity, but of a reality hidden from direct sight. And so the search for dark matter continues, not because modified gravity is without merit, but because the cosmos has spoken through evidence too weighty to ignore. The invisible scaffolding remains the best explanation, a silent presence that resists erasure. Yet the story of Mond and its descendants leaves a lingering truth. Physics is not static. The laws that govern the universe are not scripture, but hypotheses forever tested by the cosmos itself. To question Einstein is not folly, but fidelity to science. For even the greatest theories must be ready to fall before the weight of new evidence. The universe, after all, has no obligation to remain simple. Its truths may be stranger, more layered, more elusive than even the boldest theories dare to dream. In the struggle between dark matter and modified gravity, humanity is reminded of its place, not as masters of the cosmos, but as students, forever revising their understanding under the cold and impartial gaze of the stars. And in that humility lies both the frustration and the beauty of science. For the quest to know is not measured by certainty, but by the courage to explore what might lie beyond even Einstein.
In the silence of creation, the universe grew from a nearly uniform sea of energy and matter. Tiny ripples, fluctuations imprinted in the first fraction of a second after the Big Bang, carried within them the seeds of everything to come. From these faint imbalances, gravity began its patient work, drawing matter together, amplifying the small into the vast. But ordinary matter, the atoms of hydrogen and helium, the substance that would one day ignite into stars, was not enough. On its own, it was too restless, too easily scattered by radiation. In the early universe, before the first stars, visible matter was like dust in a storm, tossed about by the intense light of its surroundings. Without something heavier, something colder, something invisible, it could never have formed the galaxies and clusters we see today. It was dark matter that steadied the hand of creation. Acting as a silent skeleton, dark matter clumped together first, immune to radiation, shaping wells of gravity where ordinary matter could eventually gather. In the great cosmic competition, dark matter won the race to structure. Where it gathered, galaxies would bloom. Where it was absent, voids would remain. Modern cosmology has made this invisible architecture visible, not through direct sight, but through simulation. Using supercomputers, astrophysicists have recreated the universe in digital form, seeding it with the physics of gravity, expansion, and dark matter. The most famous of these, the Millennium Simulation, traced the evolution of 10 billion particles of dark matter across 2 billion light-years of space. What emerged was a universe woven into filaments, strands of invisible mass stretching like cosmic highways, with galaxies forming along their lines. In these simulations, the difference between a universe with dark matter and one without is profound. Without dark matter, galaxies form late, fragile, scattered like sand. With dark matter, the cosmic web takes shape, filaments binding clusters, clusters merging into superclusters, and great voids stretching between them like the black spaces of a spider's web. The universe acquires order, structure, and endurance. The filaments themselves are astonishing. They span hundreds of millions of light years, connecting clusters in delicate bridges of matter too faint to see directly, yet revealed through gravitational lensing and the distribution of galaxies. Between them lie the voids, immense, dark abysses where matter is scarce, expanses so empty that entire galaxies can drift alone in their silence. Together, filaments and voids form the hidden skeleton of the cosmos, an architecture of unimaginable scale. In this web, galaxies are not solitary. They are beads strung upon invisible threads, their fates tied to the underlying map of dark matter. Even the Milky Way, with its spiral arms and brilliant stars, is just one pearl upon a filament stretching across the local universe. Its neighbors, Andromeda, Triangulum, the smaller dwarfs, are not randomly placed, but arranged along the scaffolding of the unseen. Observations confirm what simulations predict. The Sloan Digital Sky Survey, charting millions of galaxies, revealed the cosmic web with striking clarity. What the eye sees as a scatter of galaxies is, at large enough scales, an intricate network. Patterns of clustering, vast walls of galaxies, and yawning voids align almost exactly with the predictions of dark matter cosmology. It is as though the universe itself has been sculpted by an invisible hand, and the galaxies are mere tracings of that deeper shape. This architecture is not static. Over billions of years, the web has evolved, growing thicker and more intricate as gravity pulls matter inward. Filaments feed galaxies with a steady stream of cold gas, fueling star formation. In some regions, clusters merge in violent collisions, shockwaves rippling through plasma, while in others, galaxies fall into filaments like rivers joining a greater flow. The dark web is alive with motion, a vast circulatory system that sustains the visible cosmos. And yet, the web remains mostly invisible. Astronomers detect it indirectly, through the distortions of background light or the faint glow of gas that clings to its strands. Recent observations using instruments like the Muse spectrograph on the Very Large Telescope have begun to glimpse filaments directly, capturing wisps of hydrogen illuminated by nearby quasars. These fleeting images confirm what theory has long suggested, that galaxies grow not in isolation, but by drawing from the veins of the cosmic skeleton. This raises profound questions. If dark matter is the framework upon which galaxies are built, then the visible universe is but a reflection of the invisible one. Stars and planets, and all the life that depends upon them, exist because an unseen web first made the cosmos fertile. Without dark matter, there would be no galaxies, no stars, no Earth. The very possibility of observers to ask these questions is owed to the silent architecture of the dark. It is a humbling thought. Human beings navigate by the stars, measure time by their light, and dream of distant galaxies. Yet those galaxies owe their existence to something unseen, something that never shines, never burns, but only holds. The familiar universe, the one traced by constellations and spiral arms, is but the skin. Beneath it lies the true skeleton of creation. The cosmic web also reminds humanity of scale. In its filaments, stretching across hundreds of millions of light years, The place of the Milky Way is reduced to a point along a thread. Even superclusters are but knots in the greater net. To trace the web is to glimpse the immensity of the cosmos, a structure so vast that the mind can scarcely hold it. Yet within its vastness lies unity. The same dark matter that sculpts a distant cluster also shaped the cradle of the Milky Way. The same filaments that thread the depths of the Virgo cluster also tug faintly upon Earth. The architecture of the dark is not remote. It is the very framework of the space we inhabit. Cosmologists continue to refine their maps, using ever larger surveys and more sensitive instruments. The Dark Energy Survey, Euclid, and the upcoming Nancy Grace Roman Space Telescope aim to measure the geometry of this web with exquisite precision. Each new observation sharpens the portrait, confirming again and again that dark matter is the silent architect. Still, mystery endures. What is this substance that sculpts the universe, yet refuses to reveal itself? If dark matter is made of particles, then they are unlike any ever detected, immune to the forces that govern atoms and light. If it is something deeper, a modification of space-time, a relic of extra dimensions, then the architecture itself may hold clues to new physics. In the great tapestry of the cosmos, silence is not the absence of sound, but the absence of presence. A silence born not from stillness, but from distance. It is the silence that grows as galaxies drift apart, carried by an invisible tide whose nature remains among the deepest enigmas of science. That tide is dark energy. For most of cosmic history, gravity reigned as the sculptor. Its invisible hand drew matter together, binding gas into stars, stars into galaxies, galaxies into clusters. The expansion of the universe, born in the Big Bang, was steadily slowed by this great attractive force. Astronomers expected that gravity's patient pull would continue forever, perhaps one day halting the expansion entirely, or at least slowing it towards stillness. But in the late 20th century, the cosmos betrayed that expectation. Observations of distant supernovae, stars dying in violent thermonuclear brilliance, revealed something astonishing. Instead of slowing, the expansion of the universe was accelerating. Space itself was stretching faster with time, not slower. The discovery, announced in 1998 by two competing teams, was as shocking as the revelation of heliocentrism or relativity. The cosmos, it seemed, was not merely expanding, it was running away. To explain this, cosmologists invoked a force unlike any other: dark energy, a pervasive pressure embedded in the fabric of space-time itself. Unlike matter, it does not cluster. Unlike radiation, it does not fade. Instead, it drives the geometry of the universe outward, a repulsion counter to gravity, yet weaker at small scales where galaxies and clusters remain bound. Across billions of light years, the imprint of this acceleration is unmistakable. The cosmic microwave background reveals the geometry of space. Galaxy surveys trace the distribution of clusters. Supernovae mark the expansion rate across time. Each line of evidence converges. Dark energy dominates the energy budget of the universe, making up nearly 70% of all that exists. The consequences are profound. In a cosmos ruled by acceleration, every unbound structure is destined to recede beyond reach. Galaxies not tethered to the gravity of the local group will, over billions of years, vanish from view. Their light, stretched by the swelling of space, will fade into invisibility until only the closest companions remain. The Milky Way itself is caught in this story. Today, it belongs to the local group, a modest cluster of galaxies bound together by gravity. The Milky Way, Andromeda, Triangulum, and dozens of dwarfs. In 4 billion years, the Milky Way and Andromeda will merge, forming a giant elliptical galaxy, a luminous island in the dark. But beyond this merged remnant, the rest of the universe will slowly slip away. The great clusters, Virgo, Perseus, Coma, will fade into distance, their light forever stretched into wavelengths too long to detect. One by one, galaxies will disappear, not because they die, but because the ocean of space expands too swiftly to bridge. The observable universe will shrink, not in size, but in content, until only the local group remains visible against a growing emptiness. This future is often described as cosmic isolation. A time will come when any astronomer born within that distant era will see a sky bereft of other galaxies. They will live in a universe that appears static, with no evidence of expansion, no trace of the cosmic web, no sign of the Big Bang. The grand story revealed by modern cosmology will be hidden, erased by the relentless expansion. Only in this present age, when the sky is still full of galaxies, can the true vastness of the universe be known. The silence dark energy brings is not immediate. It is gradual, like a whisper growing fainter as a speaker walks away. But its inevitability is inescapable. Unless dark energy itself changes, unless it evolves or decays, the expansion will continue to accelerate, stretching the fabric of space ever outward. Yet questions linger. Is dark energy truly constant, an unchanging feature of space-time, as Einstein once proposed with his cosmological constant? Or is it dynamic, a new field of physics, something that evolves across time, perhaps destined to fade or to grow stronger? Observations today cannot yet tell. They measure the strength of dark energy with increasing precision, but the possibility of evolution remains. Speculation runs further. If dark energy grows stronger with time, a scenario known as phantom energy, the universe may not merely expand, but ultimately tear itself apart in a big rip. In such a fate, galaxies would dissolve, stars would unbind, planets would shred, and even atoms would unravel, as the accelerating expansion overcomes every force of nature. This apocalyptic vision is not demanded by current data, but neither is it excluded. It remains a haunting possibility, an ultimate silence that spares nothing. Others imagine that dark energy may decay or transform, altering the destiny of the cosmos in ways not yet conceived. Perhaps acceleration will slow, and the universe may return to a gentler expansion, or even collapse in a distant reversal. In this uncertainty lies both mystery and hope, for dark energy is still largely unexplored territory. In the meantime, astronomers measure. Surveys like DESI, Euclid, and the Nancy Grace Roman Space Telescope seek to map the expansion with exquisite detail, probing whether the acceleration is truly constant or evolving. Each observation is not merely a measurement of galaxies, but of fate itself. For to know the nature of dark energy is to know the ultimate trajectory of the cosmos. The expanding silence, then, is more than a physical prediction. It is a philosophical weight. It reminds humanity of its fragile place in a cosmos whose future grows more barren with every billion years. It evokes a melancholy grandeur, that we live in the one epoch when the universe is visible in its fullness, when galaxies still cloud the night, when the web of the cosmos is still illuminated. One day, in the unimaginable future, the universe will grow quiet. Galaxies will fade, clusters will vanish, and the sky will lose its depth. The story of cosmic acceleration is not only about what is happening to space, it is about what will be lost. The dialogue between galaxies, the shared light across cosmic distances, the evidence of beginnings, all will vanish, drowned in the silence of distance. And yet, in this silence lies meaning. It shows that the universe is not static, not eternal in its present form. It is alive with change, restless, dynamic. It carries within it the seeds of impermanence, the reminder that even the cosmos evolves. Dark energy is the sculptor of destiny, its hand unseen but its influence undeniable. It will not dim the stars of the Milky Way, nor erase the planets that orbit them, but it will redraw the map of the visible universe, leaving behind islands of light adrift in darkness. The expanding silence is the legacy of a universe still writing its future. It is the hush that follows the symphony of creation, the pause before an ending that may never fully arrive. It is the reminder that in the grandest scales of time and space, even galaxies are fleeting and the night sky itself is a passing gift.
The search for the unseen cosmos does not unfold in myth or legend, but in machines of steel, silicon, and light. If dark matter and dark energy are the shadow rulers of the universe, then humanity has built colossal instruments to hunt them. Vast colliders, colossal telescopes, and delicate detectors, each one an eye straining into the abyss. These are not merely tools of measurement. They are cosmic eyes, extensions of human curiosity, crafted to pierce the veils of the universe. At the edge of Geneva, buried beneath the soil of Switzerland and France, lies the Large Hadron Collider. It is a ring of superconducting magnets, 27 kilometers in circumference, where protons are accelerated close to the speed of light and smashed together in collisions that recreate the furnace of the early universe. The LHC is not a telescope, but a kind of time machine, probing conditions just moments after the Big Bang. Here, scientists have hunted for the hypothetical particles that could make up dark matter. WIMPs born from theories of supersymmetry, axions, or other exotic fields. Supersymmetry, once a favored framework, predicted partner particles for the known ones, heavier shadows that might explain the invisible mass of galaxies. Yet, despite trillions of collisions, the detectors have remained silent. No supersymmetric particles have appeared. The absence is itself a revelation. It suggests that dark matter may not reveal itself at the energies the LHC can reach, or perhaps that it is not a particle at all. Still, the collider continues, upgraded for greater luminosity, pushing deeper into unknown territory, forcing theories to bend or break beneath the weight of evidence. Beyond the subterranean ring of colliders, other cosmic eyes gaze outward. Orbiting in the dark, the James Webb Space Telescope opens its golden petals to the deep night, capturing faint whispers of galaxies that existed billions of years ago. Though built to study formation and light, JWST also traces the scaffolding of the cosmos, the ways galaxies cluster, merge, and align, patterns guided invisibly by dark matter skeleton. Every infrared photon it gathers is shaped by gravitational architecture unseen, revealing both the visible glow of stars and the invisible hand that arranged them. On Earth, at the summit of Cerro Pachón in Chile, the Vera C. Rubin Observatory prepares to cast its gaze across the entire night sky. Equipped with the largest digital camera ever built, it will scan the heavens night after night, producing a living film of the cosmos. Galaxies will be tracked as they shift, bend, and flicker under the influence of gravity, enabling unprecedented maps of dark matter's distribution. Weak gravitational lensing, the slight distortions of starlight by invisible mass, will become a canvas of the cosmic web, a portrait painted not in ink, but in distortions of light. In orbit, the Euclid mission, launched by the European Space Agency, surveys billions of galaxies across 10 billion light-years. Its goal is audacious: to measure the geometry of the universe with such precision that the fingerprints of dark energy can be traced across cosmic time. Where the Vera Rubin Observatory captures the dynamic dance of galaxies, Euclid provides the vast geometry in which that dance unfolds. Together, they transform starlight into a language, a grammar of arcs, voids, and filaments, through which the unseen universe can be read. The pursuit of dark energy reaches even further into the faint afterglow of creation itself. The cosmic microwave background, the oldest light in the universe, still carries subtle patterns left by the first moments after the Big Bang. Projects like CMB-S4, a future ground-based experiment, will map this ancient radiation with unparalleled precision. In its ripples, cosmologists hope to read whether dark energy has remained constant or evolved, whether the cosmos is fated for eternal acceleration or a shifting, unpredictable course. Each tiny fluctuation is not noise, but a relic, a message from the primordial plasma, offering clues about what drives the universe's expansion today. But human ingenuity does not stop with light. In the 21st century, a new sense has awakened: the detection of gravitational waves. When black holes collide, when neutron stars spiral into one another, space-time itself trembles. Instruments like LIGO and Virgo have already captured these whispers. ripples stretching across billions of years to reach Earth. Soon, LISA, a gravitational wave observatory in space, will extend this ear to the universe, sensitive to frequencies unreachable from the ground. These cosmic vibrations carry information not of matter or light, but of space-time itself. And in their patterns may lie clues to the interaction of dark energy with the fabric of reality, or even evidence of exotic dark matter structures like primordial black holes. Each of these instruments, collider, telescope, detector, is an eye of a different kind, tuned to a different register of the cosmic symphony. Together, they form a constellation of human perception, straining to glimpse the unseen. Yet the silence is humbling. No particle has yet announced itself. No unmistakable signature of dark energy has yet shifted before our gaze. What emerges instead is the paradox of science. The more instruments are built, the clearer the absence becomes, and the more mysterious the cosmos grows. And yet, there is beauty in this silence. It reveals that the universe is not simple, not easily reduced to equations already written. It demands patience, humility, and imagination. It reminds humanity that knowledge is not a destination, but a horizon, always receding, always calling forward. The quest continues because the questions are too vast to abandon. What is the dark architecture that holds galaxies in their shapes? What is the force that pushes them apart, accelerating them into isolation? These are not questions of physics alone, but of existence itself, for they determine the fate of time, space, and every future observer who will look up at the night sky. The colliders will keep smashing particles, searching for whispers of the invisible. The telescopes will keep watching, mapping the shifting tapestry of stars. The gravitational wave detectors will keep listening for the tremors of space-time. And through them, humanity will continue to press against the darkness, seeking not only to see, but to understand. For in these cosmic eyes lies a simple truth. The universe is greater than what it reveals. And every unanswered question, every silent detector, every unexplained pattern is not failure, but invitation. An invitation to look deeper, to build grander eyes, and to continue the timeless dialogue between the known and the unknown.
When the known begins to falter, imagination must step forward. Science is not only a cathedral of measurement, but also a theater of speculation. Where telescopes and colliders fail to yield answers, hypotheses grow bolder, reaching beyond familiar ground, probing realms where mathematics whispers of possibilities more alien than myth. Dark matter and dark energy, the invisible majority of the cosmos, have invited precisely this. If they cannot yet be seen, perhaps they can be reimagined. One radical idea suggests that dark matter might not be a particle at all, but a collection of primordial black holes, born not from collapsing stars, but from quantum fluctuations in the earliest moments of inflation. These ancient singularities could still roam the universe, hidden in its shadows. Unlike the massive black holes at galactic centers, primordial black holes could range from asteroid-sized to planetary mass, invisibly drifting through space. They would not emit light, but their gravity could explain the missing mass in galaxies and clusters. Microlensing surveys, where a black hole briefly magnifies a background star as it passes in front, have searched for them, setting limits on their abundance. Some data hint at their possibility. Most exclude them as the full answer. Yet the idea lingers, provocative and haunting, for it ties the problem of dark matter to the earliest quantum tremors of creation itself. Others extend speculation to realms beyond visible dimensions. What if dark energy is the echo of higher dimensions, a force bleeding into our three-dimensional universe from a larger framework of reality? In theories of string cosmology and brain worlds, our universe may be a membrane adrift in a higher dimensional space. The repulsive push of dark energy could be nothing more than the warping of that hidden landscape. In such visions, the acceleration of galaxies is not merely an intrinsic property of space-time, but a sign that our cosmos is influenced by worlds unseen, a reminder that reality itself may have depth beyond perception. At more familiar scales, quantum physics provides another radical avenue. The vacuum of space, empty though it seems, is alive with restless fluctuations, pairs of virtual particles that flicker into and out of existence. According to quantum field theory, this vacuum should possess an energy density, a pressure that could behave like dark energy. Yet calculations predict a value so enormous it would tear the universe apart instantly, exceeding observations by 120 orders of magnitude. This mismatch, sometimes called the worst prediction in physics, remains unsolved. If the vacuum is truly responsible for cosmic acceleration, then some mechanism must exist to reduce its magnitude to precisely the small, gentle value we observe. The problem is not absence of explanation, but too much of it, as though the universe knows how to balance on a knife's edge we cannot yet describe. From this puzzle arises still more daring possibilities. Perhaps our universe is not the only one, but one bubble among many, a froth of inflating realities, each with its own laws and constants. In such a multiverse, dark energy could simply be a selection effect. Only universes with just the right vacuum energy permit the formation of galaxies, stars, and observers. Countless others may exist, sterile and empty, with values of dark energy too strong or too weak to allow cosmic structure. If this is true, the accelerating expansion of our universe is not explained by necessity, but by survival. The very fact that galaxies exist to ask the question would be evidence of cosmic lottery. But among the most unsettling speculations is the concept of false vacuum decay. Quantum field theory suggests that the vacuum state of the universe, the lowest energy configuration of fields, may not be truly stable. Instead, it could be metastable, a temporary plateau awaiting collapse to a deeper, more fundamental vacuum. If such a transition occurred, it would not be gentle. A bubble of true vacuum would form, expanding at the speed of light, rewriting the laws of physics within it. Particles, forces, even the constants of nature would change. Chemistry, stars, life, all would vanish instantly, without warning. No detector could anticipate it, for by the time the bubble reached us, we would already be gone. Though terrifying, this possibility is not science fiction. The stability of the Higgs field, measured after the Higgs boson's discovery at the LHC in 2012, hints that the universe may indeed sit precariously close to such metastability. Whether it will endure for trillions of years or collapse tomorrow depends on physics not yet known. Higher energies, deeper interactions, perhaps tied to the same dark energy that drives cosmic acceleration. In contemplating the false vacuum, cosmology merges with existential philosophy, the reminder that even the stage of existence itself may not be eternal. Each radical speculation reflects a deeper truth, that in the quiet reaches of thought, beyond the mathematics and the instruments, a different question lingers. What does it mean to live in a universe where most of existence cannot be seen? If the visible stars, galaxies, and planets, all the familiar splendor of the night sky, amount to less than 5% of reality, then humanity's knowledge is revealed as a fragile lantern, flickering in a darkness far greater than it can dispel. This revelation is not merely scientific. It is philosophical, even existential. For every discovery that lifts the veil of the cosmos, a deeper shadow is revealed behind it. Dark matter, unseen yet gravitationally binding the galaxies. Dark energy, silent yet prying them apart with growing speed. These invisible forces shape everything, yet they escape all direct perception. What humanity calls reality may be little more than the reflection of structures it cannot touch, a silhouette cast by powers beyond comprehension. The ancients spoke of shadows, too. In the dialogues of Plato, a cave is imagined, where prisoners are bound in darkness, watching shadows flicker on the wall, mistaking them for the fullness of truth. Only one who escapes the cave and sees the sun beyond can understand the source of those fleeting illusions. Modern cosmology has rekindled this metaphor on a cosmic scale. Humanity, for all its telescopes and colliders, remains bound within a cave of its own, a cave where the visible cosmos is only a shadow, projected by an invisible architecture of dark matter and dark energy. The galaxies that gleam like lanterns across the night sky are not the whole truth, but reflections of something deeper, unseen, perhaps unreachable. This tension between the visible and the hidden is not new to science. Albert Einstein once reflected that the most incomprehensible thing about the universe is that it is comprehensible at all. That thought holds even greater weight now. For if the human mind can sketch equations to predict the orbit of a planet, if it can measure the faint afterglow of the Big Bang, if it can glimpse the birth of stars in the cold depths of space, then it seems a miracle of thought itself. But against this triumph, the incomprehensible looms larger. That 95% of the cosmos remains invisible, as though reality has withheld its most essential chapters from our reading. And yet, perhaps comprehension itself is a relative word. To the prisoners in Plato's cave, the shadows were once truth. To humanity today, the luminous galaxies are truth. What will the future reveal? Perhaps these, too, are only shadows, cast by deeper laws and structures not yet known. The lesson is humbling, that truth is not absolute, but unfolding, and that each generation peers only a little further beyond the cave wall. The philosophical reverberations extend further still. If so much of the universe is unseen, then the question of reality itself becomes slippery. Is reality what can be measured? Or is it what exists, whether measurement reaches it or not? By one definition, dark matter and dark energy are real. Their effects are undeniable, etched in the movement of galaxies and the acceleration of expansion. Yet by another definition, they remain abstractions, placeholders for ignorance, names given to mysteries not yet understood. Science treads carefully here, balancing between what is inferred and what is known. But for philosophy, the very act of naming the unknown becomes symbolic, an admission that the human mind is surrounded by frontiers it cannot yet cross. There is also a moral echo. To dwell in such a universe is to confront humility. Human civilization, so preoccupied with the dramas of its surface, with borders, economies, conflicts, and ambitions, exists inside a reality almost entirely invisible. The stars themselves are not the whole picture, only fragments of a greater order. If nothing else, the darkness teaches perspective, that human struggles are small beside a cosmos whose true nature remains hidden, vast, and enduring. At the same time, there is wonder, for though most of the universe is unseen, the very capacity to notice this absence is extraordinary. To measure a gap of 95% is to touch the outline of the unknown, to sense the architecture of mysteries yet unsolved. This is not failure. It is promise, the recognition that there are truths still awaiting discovery, perhaps truths that will redefine what real means. And so the reverberations stretch outward, into philosophy, into meaning, into the timeless question of humanity's place. The cosmos is both generous and withholding, offering glimpses of its grandeur while cloaking its essence. Like the shadows of Plato's cave, the galaxies may be only the surface of deeper realities. Like Einstein's reflections, the universe remains both comprehensible and incomprehensible at once, a paradox that defines the human condition. Perhaps the greatest lesson is not despair, but awe. To exist in a universe where the majority is unseen is not to be diminished, but to be invited into a journey of thought, of discovery, of humility before the unknown. The shadows on the cave wall are not the end of the story. They are the beginning. The reverberations, then, are not only philosophical. They are personal, cultural, civilizational. For to look at the night sky with the knowledge that it is mostly darkness is to recognize the limits of perception, the fragility of certainty, and the possibility that truth lies always beyond the next horizon. It is to live not with answers, but with questions, and to find meaning not in completion, but in the endless pursuit. In this, humanity is both prisoner and explorer, both bound within the cave and reaching toward the sun. Dark matter and dark energy are not only scientific mysteries. They are mirrors, reflecting the deeper condition of human thought. that to understand is always to stand at the edge of the unknown and to wonder what lies beyond.
The universe is not static. It is not eternal in its present form. It is a story in motion, and like all stories, it carries within it the weight of an age. From the fiery birth of the Big Bang to the slow sculpting of galaxies, the cosmos has unfolded as a tale of creation and transformation. But hidden within the silent pull of dark matter and the invisible push of dark energy lies the most haunting of all questions. How does the story end? For centuries, cosmology sought comfort in cycles and certainties. The ancients spoke of eternal returns, of worlds born and destroyed in infinite succession. Even modern science once entertained the notion of a steady state, where galaxies might form forever in balance, with no beginning and no end. But observation has dissolved such illusions. The universe is expanding, and that expansion is not slowing down, it is accelerating. Dark energy, the mysterious force behind this acceleration, holds in its grasp the destiny of everything. One possible fate is the cold silence of heat death. In this vision, the expansion never ceases, but races onward through eternity. Stars exhaust their fuel, galaxies fall into stillness, and black holes slowly evaporate into faint whispers of radiation. The cosmos grows colder, darker, thinner, until every particle of matter is scattered across a void stretched beyond recognition. There is no drama here, no violent finale, only the slow extinguishing of light, a universe dissolving into an endless night. It is the ultimate entropy, a silence without end. Yet another possibility is far more violent, far more terrifying. If dark energy is not constant, but grows stronger with time, if it is a phantom energy whose pressure deepens with every moment, then a future known as the Big Rip awaits. In this cataclysm, the accelerating expansion does not merely separate galaxies. It intensifies until it rips galaxies apart themselves. Stars are torn from stars, planets ripped from orbits. Even atoms cannot withstand the onrush until the very fabric of matter is sundered. Time itself may end not in silence, but in rupture, a cosmic scream of destruction. There are other visions, too. Some theorists imagine a universe where dark energy is not permanent, but reversible, a dynamic field, a force that might one day weaken or even change sign. In such a cosmos, the expansion could slow, halt, and reverse. The galaxies, now racing outward, would begin to fall inward, drawn back toward a new convergence. A great contraction would unfold, collapsing the universe into a fiery singularity, a mirror to the Big Bang, a cosmic rebirth. In this cycle, universes might rise and fall eternally, each one echoing the last, each one perhaps subtly different, a symphony of creation and destruction repeating across eternity. Science does not yet know which of these fates awaits. The answer lies hidden in the precise nature of dark energy, a mystery that current telescopes and equations cannot yet resolve. Is it a constant, unchanging presence, the cosmological constant Einstein once sketched into his equations? Or is it a dynamic field, evolving with time, shifting with the deep structure of reality? The distinction is not small. It is the difference between an eternal silence, a violent ending, or an infinite cycle of cosmic rebirths. And so the fate of the universe rests upon something still unseen, still unnamed. A force that cannot be touched, but whose fingerprints mark the galaxies across billions of light years. The emotional weight of these possibilities cannot be ignored. To imagine heat death is to picture the ultimate loneliness, a universe stripped of stars, where even memory fades. To imagine the Big Rip is to confront a universe undone in chaos, where even the bonds of atoms surrender to expansion. To imagine cycles is to wonder if all this, the galaxies, the stars, the fragile emergence of life, has happened before and will happen again. Each vision is a mirror, reflecting humanity's own fears and hopes. In the silence of heat death, one sees the inevitability of decay. In the fury of the Big Rip, one sees the fragility of all structure. In the cycle of rebirth, one sees a glimmer of continuity, of meaning beyond endings. The cosmos, in this way, becomes not just a physical story, but a philosophical one, a stage upon which the questions of mortality, purpose, and eternity are projected on the largest scale imaginable. Yet perhaps the deepest truth is this: the universe does not promise answers. It does not reassure with certainty. Instead, it invites wonder. The galaxies, rushing apart, remind humanity of the transience of all things. The acceleration, measured in faint supernova light, whispers that even the stars are temporary. And the unknown nature of dark energy, shaping destiny itself, reminds us that reality is larger than imagination. In the end, the fate of the dark universe is not yet written. Its silence, its violence, its cycles remain possibilities awaiting discovery. What remains certain is only this: that the cosmos is moving toward a future shaped by forces unseen, and at every moment humanity gazes at the night sky, it gazes not only at its past, but at its destiny. The galaxies drift, the stars burn, the silence deepens, and somewhere beyond human knowing, the future of everything is already unfolding. In the measureless expanse of the cosmos, human beings stand as fragile sparks, a single species confined to a pale blue planet, orbiting an ordinary star on the outskirts of an unremarkable spiral galaxy. Against the backdrop of a universe laced with filaments of dark matter and driven apart by the invisible breath of dark energy, humanity's presence appears almost imperceptible, like the faint flicker of a candle in an endless night. All that is visible, the stars, the planets, the glowing arms of galaxies, forms less than 5% of the whole. 95% of the cosmos is unseen, existing as a shadowy architecture and an invisible force, guiding galaxies yet eluding comprehension. Human life unfolds not upon the central stage of reality, but upon the thin surface of an unfathomable abyss. Existence itself rests on scaffolding made of ghosts. Yet it is precisely this recognition of smallness that lends human searching its weight. To know that one is dwarfed by mystery and still to ask questions, this is not weakness, but courage. The act of gazing into the unknown becomes, in itself, a defiance of cosmic silence. When Fritz Zwicky first spoke of Dunkel Materie, when Vera Rubin traced the impossible velocities of stars, when scientists built underground chambers filled with liquid xenon in the hope of glimpsing unseen particles, each moment testified to an unwillingness to accept darkness as final. Humanity's tools remain delicate. Telescopes catch faint photons that have traveled billions of years, whispering fragments of ancient stories. Detectors deep underground listen for particles that may never come. Theorists wrestle with equations that strain the limits of comprehension. Yet these efforts, however incomplete, embody something more profound than results. They reveal the longing of a species that refuses to dwell only in the visible. For it is in the shadows that meaning is often forged. The invisible scaffolding of dark matter shapes the galaxies that cradle stars. The ungraspable hand of dark energy writes the fate of expansion. And in parallel, the invisible scaffolding of human thought, curiosity, wonder, persistence, shapes the search itself. Both are unseen. Both hold immense power. In contemplating the cosmos, humanity confronts more than physics. It confronts itself. To ask what lies beyond sight is also to ask what lies within. The recognition that reality is dominated by unseen forces mirrors the recognition that the human condition itself is ruled by mysteries not yet solved. The nature of consciousness, the origin of life, the question of meaning. The shadows of the universe reflect the shadows of existence. And still, there is beauty in the search. The courage of astronomers staring through the blackness. The patience of physicists waiting decades for a signal that may never come. The humility of admitting ignorance before the immensity of space. These acts transform the unseen into a kind of light. They remind that even if humanity never grasps the final answer, the pursuit itself carves meaning into the silence. Perhaps the deepest truth is not whether dark matter is a particle or whether dark energy is constant or evolving. Perhaps the truth is that the universe, in hiding so much of itself, is inviting humanity into an eternal dialogue, a conversation with the unknown that defines the very essence of being human. To live in shadows, and yet to reach toward light. The galaxies will continue to drift apart. Stars will be born and die, regardless of human presence. Dark matter will weave its hidden skeleton, and dark energy will stretch the fabric of space. Humanity may never command these forces, may never solve their final equations. Yet in choosing to seek, to listen, to wonder, it inscribes its own meaning into the cosmic story. In the end, humanity may be a shadow within shadows, but it is a shadow that looks back at the abyss and dares to ask, why? And in that question, fragile though it is, lies the quiet defiance of a species that refuses to surrender to darkness. For even in a universe ruled by ghosts, the act of searching becomes its own light.
There is a silence that lies deeper than sound. It is the silence of the cosmos, stretching beyond horizons, where light itself is too faint to return. Within that silence, galaxies burn and fade, planets rise and vanish, and stars scatter their ashes into the currents of time. Yet beneath all this brilliance lies a haunting truth. The universe that dazzles human eyes is but a fragile surface, a shimmering embroidery upon a far vaster, unseen fabric. The visible world, the stars overhead, the glowing arms of galaxies, even the atoms that compose life itself, is only the faintest whisper of existence. Beneath it lies a hidden empire, dark matter, shaping the skeleton of the cosmos, dark energy, pushing space into ever-accelerating flight. Together they rule over 95% of all that exists, and yet they remain invisible, unknowable in form, their essence concealed behind veils that no telescope has pierced. This revelation does not diminish the beauty of the cosmos. Instead, it amplifies it, transforming the night sky into a riddle without end. Every cluster of stars becomes a question. Every filament of galaxies, a signature written in a language beyond comprehension. The universe reveals just enough to ignite wonder and withholds the rest, as though daring consciousness to follow further into the abyss. In this pursuit, humanity discovers not answers, but itself. For to live in mystery, and to still reach outward, is an act of defiance against the silence. Each equation written on chalkboards, each photon captured by orbiting telescopes, each cavern hollowed deep underground to listen for invisible particles, these are gestures of resistance against cosmic obscurity. They are the poetry of a species unwilling to surrender to ignorance. Einstein once confessed that the most incomprehensible thing about the universe is that it is comprehensible. But perhaps its greatest incomprehensibility lies in what resists understanding. The universe does not present itself as a completed book. It offers fragments, torn pages scattered by cosmic winds, while the binding remains hidden. The task of humanity is not to finish the book, but to continue turning the pages, even when the ink grows faint. Consider what lies ahead. Galaxies, carried on the tides of dark energy, will drift farther apart until their light no longer reaches one another. To distant eyes, the universe will appear empty, a night sky stripped bare of stars. Isolation will deepen, and silence will grow. Yet even in this fate, there is a kind of poetry, the story of a cosmos that begins in brilliance, matures in shadow, and ends in quiet dispersal. And within this fleeting interval, this narrow window of cosmic time, humanity exists. A fragile species balanced between ignorance and knowledge, surrounded by mysteries that dwarf its comprehension, yet still moved to search. The courage of this searching is its legacy. It is not certainty that defines a civilization, but the willingness to ask questions against the darkness. Perhaps dark matter will one day be revealed as a particle, caught in the depths of an underground chamber. Perhaps dark energy will be explained by hidden dimensions, or a field stretching across the vacuum of space. Perhaps neither will ever yield their secrets. The outcome does not erase the beauty of the attempt, for in the act of reaching, humanity writes its own meaning into the void. In the end, the cosmos remains a mirror. It reflects back not only the laws of physics, but the character of the species that studies it. To stand before an infinite night, knowing that what is seen is only a shadow of what exists, and still to gaze upward in wonder. This is the essence of being human. It is humility braided with courage, ignorance entwined with hope. The universe may never give its final answers. Its truths may remain scattered across horizons beyond reach, its scaffolding of dark matter forever invisible, its breath of dark energy forever abstract. Yet the beauty lies not in the destination, but in the path itself. The journey through mystery is the poem, and humanity is the voice that recites it, trembling but unbroken, into the silence. So the galaxies drift. Their light spreads into darkness, their structures dissolve into distance, and the great unseen forces, quiet, unyielding, continue their work, sculpting a reality that human eyes can only glimpse. This is the haunting poetry of the unknown, that the universe is larger than comprehension, deeper than imagination, and more mysterious than any story it inspires. And in that mystery lies its beauty. For even when ruled by shadows, the cosmos invites wonder. And even when surrounded by ghosts, humanity dares to search.